I am Dr. Jagan Mohan from Aeronautical Department, Institute of Aeronautical Engineering. Today we will discuss about the topic subject, that is power system protection. So the power system protection is important because since the power system contains of generation of electrical energy, the first part, and transmission is the second part, and distribution is the third part. So here, if you are unable to protect this system, there will be so many faults occurring in the system which will damage the system, ultimately leading to the shortage of the supply. So the title here is the circuit breakers. So this the course outcomes. So in the unit 1, we are going to focus on the summarize the current energy scenario. So if you are having an idea of the current energy scenario, so based on this we can plan for the future energy supply, or we can predict the future energy requirement. So that's why we have to focus on the current energy scenario. Next, the thing is CO1 is focusing on environmental impact. So because there is so much of environmental impact by the power system, especially if you are producing with the thermal power, especially with the coal energy. So this is the thing we have to keep it in mind and plan for the production or conserving the power produced. So we cannot decrease the power, because for industries, for any economical development of a country, the power is very, very important. So but keeping in mind about the environmental impact, so we can control the pollution, or we can take the necessary steps needed. Next thing is energy sector reforms for policy programs. So these energy sector reforms are for facilitating the public. So regarding the industrial load, regarding the commercial load, regarding the agricultural load, regarding the domestic load. So based on these reforms, and we have to plan the future, and we have to plan the future of the power system and power system protection. So, and implementation of energy conservation activities by the government. So here the production we are increasing day by day, but it is not as proportional to the increase of the demand. So that's why the alternative thing and also good thing which we have to focus is about the energy conservation. So if you are able to conserve to the maximum level, so we are able to decrease the cost, we are able to decrease the loss, we are able to decrease the pollution. All these things comes by focusing on the energy conservation. Next, CO is focusing on the illustrate the types, methods and instruments for conducting energy audit. So here we have to conduct the energy audit, and this is helpful in the conserving and feature plan. So I have to interpret the power factor and load management, all these things. Identify the efficiency, CO4 is focusing. Make use of the energy efficient technologies. So here, when you come to the circuit breaker, so basically what is a circuit breaker? So it is a device. So in the name itself, it is there. It is able to break the circuit or make the circuit. It is a switching device. It is a mechanical device. So it works manually or automatically. So the fault occurs suddenly. The fault occurs suddenly without any intimation. So it has to act suddenly. That means it should be able of operating both automatically or manual. So the circuit breaker is a switching device that carry mechanical switching device that carry or break a circuit either manually or automatically under normal and abnormal conditions. So generally, abnormal condition we have to break. Sometimes during servicing also we have to break the circuit. The characteristics of a circuit breaker. So circuit breaker is having the capacity. The circuit breaker is having the capacity to make or break manually or automatically, or sometimes we can use the remote control. So generally, abnormal conditions, we are going to use the remote control. So under abnormal or fault conditions, it can break the circuit automatically. Okay. If it is having, if it does not have that capacity of functioning automatically, so if it fails, there is a chance of occurring so much of damage to the circuit breaker or the power system. So that's why we have to see such that it is both manual and automatic. If it is, if the surge is very high, that means if the fault is very high, so it is going to isolate the circuit. That's why it is called as the circuit breaker. Actually, we can, in simple form, we can say it is a developed fuse. So in our houses in olden days, we are using to use the fuse. Now we are using circuit breaker. So that means it will burn and it will break. So the current cannot pass further. So the same thing, the developed fuse technology, we are calling it as circuit breaker. So these are the characteristics which are making the circuit breaker as the best for power system protection. So during the transmission, we'll be transmitting very high amount of power, which will create so much of damage. So this type of arrangement is very, very necessary. Next thing is the principle of operation of circuit breakers. The only target of the circuit breaker is to break whenever it is needed repeatedly. How many times it is needed repeatedly, it has to break. That means if it is breaking, means there should be some mechanism which is moving away the contacts. So such type of mechanism is available here. The main duty of a circuit breaker is to switch on and off the electrical circuit during the normal and abnormal conditions correspondingly repeatedly, whenever it is needed repeatedly. So normal conditions, it will not break. So if it is on means it will break. So if the coil gets energized, it will break. The operating principle of circuit breaker is very simple. So we'll be having a two contacts called as electrode. So which are having the capability of moving whenever the fault occurs. Or whenever it is needed. So under normal condition, these contacts are closed. So that means allowing the supply to pass. So that means making the circuit. So current is passing. So whenever they are closed, so it's like switch. So whenever it is closed, the current will circulate. If fault occurs, it will open. It will open either manually or automatically. Manually means sometimes during maintenance. Okay. So under fault condition, what happens is we'll be having a trip coil. That coil will get energized. Resulting contacts to move away and opening the circuit. So if the contact is closed, so for the supply, for circulation for the electricity to pass, a closed circuit is needed. So if the contacts are closed, the electricity will pass, and whenever it is needed or whenever in the fault conditions, whenever in the surge conditions, okay, it will open. That means the circuit is open. So the current cannot pass. That is the way it is able to protect the system. So here the main problem with the circuit breaker is there is a phenomenon which is called as the arc phenomena. So we are placing the circuit breaker for the power system protection, and it will open the contacts. Under the normal condition, they will be closed and the current will be passing. The circuit will be functioning. The circuit is not broken. So under abnormal conditions, the coil gets energized. The trip coil gets energized and the contacts will move away. That means electrodes will move away to break the power supply or passage of the electricity. Even after these electrodes move away, there is a phenomena called as arc phenomena, which is making the supply unbreakable or circuit unbreakable. So immediately when we are moving these contacts away, a arc is struck between these contacts. So until the arc exists, this supply is able to pass continuously. So this arc is not only creating damage to the circuit breaker, and also sometimes it will create damage to the entire power system. You can imagine a surge, how much powerful it could be. So during this arc, the disadvantage is not only the failure of the purpose or passage of the electricity, there is an enormous amount of heat is also produced. Okay, so we are we are moving, we are separating the contacts. The circuit breaker is separating the contacts for the purpose of breaking the electrical supply or breaking the circuit. That purpose is not getting solved. This is a major challenge. Arc phenomena occurs during opening of the contacts. During separation of contacts, an arc is struck between the contacts. Until the arc discharges, the current continues to flow. Arc delays the circuit interruption, that means circuit breaking, and produces significant heat which can damage the circuit breaker or the system, power system protection system. So we have to extinguish the arc as early as possible. So during the faulty or short circuit, so why this arc phenomena is occurring? So there is little bit we have to understand about this arc, about the medium, about the potential difference, about the ionization. So then we can understand the phenomenon. So during the faulty or short circuit, large amount of current flows through the contacts before protective mechanism opens the contacts. Okay, so the current is flowing normally and suddenly fault occurs or short circuit occurs. So that means more amount of current is passing. So it is already happened before the protective system gets activated. Okay, before the protective system gets activated, the sum of the large current has already passed through these contacts. So if it is not passed, it can perfectly act as there is no question of occurring, striking the arc. So before this protection system gets activated itself, a large amount of current or short circuited current or fault current, some amount of the current already passes through these contacts. The moment contacts start to open, so because already more current is passing through these contacts, so there is some delay. There is a time, because there is a time delay. So the action, the correction has started after the action. So even these are getting separated. The contact area is suddenly reduced and the current density increases because it is a large current. Due to large current, or it is a short circuit current. So this current density, this large current is enough to ionize the medium, whatever the medium it may be, and making the current to continue, or striking the arc, making the current to continue, and spoiling the purpose of circuit breaking. So this leads to rise in temperature, and the heat produced is sufficient to ionize the medium. It may be air or oil. So now, the high current which has started passing before the action is the cause for producing this heat and making the medium, and this ionized medium acts as a conductor. So this ionized medium is nothing but the arc. That is, arc is struck between the contacts. So this arc provides a low resistive path, and this arc continues, and the current supply and the current transmission continues, and the large current continues to flow as long as the arc exists. So that means even if you have separated these nodes, even though you have separated the nodes, this arc has given the supply a low resistance path to get continued. So which is spoiling the purpose of the circuit breaking. So what is the reason for the arc? Before understanding the methods, so we are having methods to extinguish this arc, and so if you want to extinguish this arc, we have to understand about this arc and the contacts of the circuit breaker. The reason can be confined, that is potential difference and the ionized particles. So these are the main reasons. So the potential difference between the contacts and ionized particles between the contacts. The potential difference between the contacts is sufficient for the arc to exist, as the separation between the contacts is less, and also the distance will be less. This is also another factor which is creating the arc. And also the ionized medium, maybe it is air or oil, have a tendency to continue or maintain the arc. So as long as the arc exists, the supply exists, and supply continues. So we are having different methods for arc extinction, that is high resistance method and low resistance method. So in high resistance method, the resistance of the arc is increased, so the current will become insignificant to maintain the arc. So here we are increasing the resistance, that means discouraging the current. And another thing is for another procedures for this increasing the resistance is increasing the arc length, cooling the arc, reducing the area of cross section, splitting the arc. So these are the possible things we can do for this increased resistance method. So generally this method we are using in DC circuit breakers and low capacity AC circuit breakers, as it produces more heat during arc extinction. So during the arc extinction, so much amount of heat is produced. So because we are increasing the resistance, so that's why we are using this type of method we are using in the DC and low capacity AC circuit breaker. So another method is low resistance method. Here we are waiting the current to get extinguished naturally. That means here the resistance of the arc maintained low. So we are not opposing, we are allowing low resistance until the current becomes zero. That's why it is also called as the zero current method. This low resistance method is also called as the zero current method, and this we are using in high power AC circuit breakers, because low power AC circuit breakers we are using high resistance. So because if we are using the high resistance in high power circuit breakers, imagine how much amount of heat is produced. That's why we are using this method in the high power, low resistance method in the high power, and high resistance method in the low power AC circuit breakers. And also it will prevents the restriking of the arc even when the voltage across the contacts rises. So due to this method, the restriking problem is also solved. And another thing is, we have to consider the ionization of the medium and the tendency of ionized particles to maintain the arc. So if the medium between the contacts is deionized, so main things are potential difference and ionization of the medium. So ionization, so for that we are providing high resistance and low resistance method. So ionization means here the medium between the contacts we have to deionize. So ionization is the main reason here for providing the medium. So we have to deionize as quickly as possible. The possibility of restriking can be reduced significantly. So the deionization process. So that is, we have to increase the gap between the contacts, increase the pressure, cooling the arc, and also gas blast. So these are the methods for controlling the arc, for decreasing the arc as quick, for extinguishing the arc as quickly as possible. So low resistance method, high resistance method, and deionization. And there are so many types of circuit breakers based on the medium we are using. Okay, they are air, oil, sulfur, hexafluoride, gas, or vacuum circuit breakers, and we will go about these circuit breakers in detail in the next class. So here in this class we have seen first what is a circuit breaker. It is basically a mechanical switching device. Okay, so whenever it is needed, we can break the circuit manually or automatically under normal or abnormal condition. That means fault conditions or maintenance conditions. So what is the main principle means, here we will be having two contacts which are called electrodes. So these contacts will be in contact in the normal condition. Whenever abnormal conditions occurs or short circuit conditions occur, the trip coil gets energized and the contacts are separated. So whenever the fault occurs, the coil gets energized and the contacts are separated. Under normal condition, the contact will be closed. So even after, the main problem in this circuit breaker is, even after the contacts are separated or open, an arc is struck between these contacts, and until the arc extinguishes, the current supply continues, and also so much amount of heat is produced which will create damage to the circuit breaker or the power system protection. So we have to extinguish the arc as early as possible. So for that, we are having low resistance method and high resistance method, and also we have to deionize the medium as early as possible. And there are so many circuit breakers based on the medium we are using, namely that is oil, gas, sulfur hexafluoride and vacuum. So low resistance method, high resistance method is used in DC and low capacity AC circuits because so much amount of heat is produced during the process of extinguishing with the help of the high resistance method. So, but low resistance method is used in the high power AC circuits. Thank you for listening.
Like, share and subscribe. Hit the bell icon for more updates.